Let's begin to look at some very important identities which we are going to use to solve problems in the subsequent videos. For example, this, where you have sine plus cos square x will always be equal to 1. Sine square x is equal 1 minus cos square x. From here, we can equally have that cos square x is equal to 1 minus sine square x. It's important you know each of these because we are going to use it to solve some problems. Another one is that 1 plus tan square x is equal to sec square x. Instead of x here, theta is used here, that's fine. Here again, 1 plus cot square theta is equal to cosec square theta. Now, because it's theta, we use theta here. If here is x, we would have used x here. Next, tan theta is sine theta over cos theta. Looking at this identity that cot, let me use x here, is 1 over tan x. But you see that this tan x is sine x over cos x. So if I put that here as cot x is 1 over, instead of tan x, I can have sine x over cos x. And if you have this as 1 divided by sine x over cos x, and you now have 1 times this will inverse to cos x over sine x, and you see that cot x is cos x over sine x. This is a very important identity to remember. The identities to remember is sine x is 1 over cosec x, and also that cos x is 1 over sec x. We can also write it the other way around, that cosec x is 1 over sine x, and we can say that sec x is 1 over cos x. Very important identity to remember. In sum and difference, if I have sine 45 plus 30, now because this is plus, I will use this identity. Hence, I will have sine 45 cos 30 plus cos 45 sine 30. Sine 45 is root 2 over 2 times cos 30 is root 3 over 2 plus cos 45 is root 2 over 2. Sine 30 is 1 over 2. For the product formula, if I have cos 45, maybe cos 30, then I should be thinking of using this identity, where I'm going to have 1 over 2, going to have cos 45 plus 30 in bracket, plus cos 45 minus 30 in bracket. Everything will be multiplied by the half. This will give you half cos 75 plus cos 15, and this will be in bracket. So If it were sine cos, maybe sine cos, I should be using this. If it is sine, I should be using this. If it is cos sine, I should be using this. In the double angle formula, sine 2a is here, can be a, it can be x, it can be theta, it can be anything. If I use x here, it's going to give me 2 sine x cos x. This is often for sine, but for cos 2x, you should be expecting cos square x minus sine square x. If you use sine square x plus cos square x is equal to 1, and you begin to put them in here or here, hence this will become cos 2x. If you substitute for sine using this, you're going to get this. If you substitute for cos, then you should be having cos 2x will be equal to 1 minus 2 sine square x. So these are the three identities for only cos. So for cos, you should be having these three identities. While for sine, it's just only this. And for tan, it's just only this. In the next video, we are going to use some of these identities to begin to solve problems. I will see you in the next video.